Here we are going to determine the first derivative of the following functions. That's number 10. It says determine the first derivative of the following functions. Hence, determine the rate of change at the indicated x value. So in other words, we have to determine the gradient function and then evaluate the actual gradient at the indicated x value. Remember, gradient is rate of change. Gradient is the slope of the line at which y varies with respect to x. So for part A now, f of x is equal to 5x raised to the power of 4 plus 2x squared. So for this type of function, which is a polynomial, all right, you have a coefficient, you've got a base, and you've got a power, or you've got an exponent. Okay, so we can use the power rule, okay, because we have powers 4 and 2. So if you want to differentiate ax to the n, a coefficient times x to the n, or let us say y, let's presume that y is equal to ax to the n. Okay, so therefore dy dx, all right, so as I was saying, dy dx is equal to nax raised to the n minus 1. What did you do? You've got to take the power, multiply it to the coefficient, and then subtract 1 from it. Okay, so to put this procedure or this rule into words, you take the power, multiply it to the coefficient, that will give you NA. You keep your variable x or whatever later, and the power now you subtract 1 from it. And you do that to each term in the polynomial. So we want to differentiate 5x to the 4 plus 2x squared. All right? So what do we do for the first term? The 4 is the power, 5 is the coefficient. We multiply 4 times 5, and you go to variable x, and you subtract 1 from 4, 4 minus 1. You repeat the same thing now for 2x squared. You multiply 2 by 2, okay, 2 up there times that 2, 2 times 2, x, and then you subtract 1 from the power 2, 2 minus 1. So 4 5s are 20, and 4 minus 1 is 3. So this term will give you 20x cubed. So that's the gradient function here, that part. And then 2 to the 4, 2 minus 1 is 2. Is 1, sorry, we have 4x. So the gradient function is 20x cubed plus 4x. Okay, that's f prime of x. So you can use that now to find the actual gradient by substituting the x value, the indicated x value, in the position of x into the gradient function to find the gradient. So x is negative 3. So we put negative 3 where x is in the gradient function here. So 20 times minus 3 raised to the power of 3 plus 4 times minus 3. Take your calculator and verify to see if this gives you minus 552. So at x is equal to minus 3, the gradient of this function is minus 552. What does that minus 552 mean? It means that every time x increases by 1, y decreases by 552. Okay? I just want to point out that there are other notations for gradient function. You have f prime of x is the same as y prime, is the same as dy dx. So all those three notations means the same thing, gradient function. All right, so here I could put f prime of x, I could put y prime, or I could put dy dx. All three notations means gradient function. So when you see a notation like that, you can say f prime, but at the same time, you can say the gradient function is. The gradient function is, the gradient function is. Okay. So, and here's the definition of gradient. The rate at which y changes when x increases by 1. X always increasing by 1, but y either increase or decrease by the gradient value. Okay, so here's an example applying the power rule. Also, I could put y prime, or I could even put f prime of x. It's the same. It means the same, just different notation. So that's what you do.